Start that. Yeah, so we will be looking at S3, EFS, EBS. That comparison we will do for the people who have just joined. Let me quickly, uh, set the context of what we are going to see in this session, and try attending it fully till the last, so that you get a crux of the important services like Aurora, RDS, S3, EFS, EBS. These are the services we are going to cover today. DynamoDB is a separate session, later on, along with Redshift and Athena. Okay. So as I was mentioning, we will first look at EBS. Now, EBS is like a disk storage attached to an EC2 instance. Okay, so it is basically attached one EC2 at a time. Think of it like if you want quick storage inside of your EC2 only. And people who don't know about EC2, it is one of the compute services in AWS where you actually run your code. Okay, and the other compute services in AWS are typically Lambda. Then you have ECS, EKS, for microservices and containerization orchestration, right? And here one important point to note is that, just a small, is that although it is attached to one EC2 at a time, but if EC2 some because of some issues, if EC2 is getting terminated, EBS will still survive, but if the availability zone in which that EC2 is kept, if that itself is terminating, then EBS will also terminate, or it will die. So it is attached to one EC2, but it doesn't die if ECS is dying. But if the AZ itself is dying, then EBS also dies. Okay, so this is one important thing to note, and this is how you compare ECS versus EFS and all. So I've just quickly also put the important notes here. It is single EC2 attachment, AZ scoped. Okay, it is EBS volumes, whatever are there, they will reside within an availability zone. Availability zone are nothing but different zones in a region. So let's say you have a Mumbai region. In this Mumbai region, what AWS does is it will have multiple availability zones on which the data is replicated, so that if one zone is terminated due to whatever power outage, etc., you still have fault tolerance. So the entire workload can be shifted to other zones without any major impact. Okay, that's the so basically, to isolate, for fault isolation is what we call it, you have different availability zones in a single region. Okay, and it survives EC2 termination. As I mentioned, data will still remain intact even though EC2 is getting terminated, or it is dying. But if the AZ itself is dying, then EBS also will die. Okay, these are the important points. These are the best use cases, and try taking the notes. It will help you, because the idea is that I wanted to keep it as simple as possible, so that we discuss all the major points without confusing ourselves too much, for people who are just starting out. And as I see, more or less we have people who have less than 5 years of experience in AWS, or there are people who are just starting out, as I have taken the poll. So it becomes even more important for us to not overwhelm ourselves and look at all the important points to be taken care of when we are trying to architect. Okay, and then you have low latency block storage, which, so what happens is, since it is attached to EC2 instance, the latency would be very low. Like, it will be a quick retrieval of the data. That's what you mean by latency. It is the time it takes to load the data and get it back into the system. So that's what is the meaning of latency. Hope everybody is aware of that. Obviously, if it's a low latency, it provides a low latency. That's the idea. So these are the major points. As I mentioned, it's very fast, persistent, but it is not a shared mechanism, which is the major difference between EBS and EFS. EFS is again, the full form is Elastic File System. By the way, any doubts you have, you can put it in the chat. We can look at it, when we have an interval in between. I'll take up those questions, or at the last, okay, whenever I get the time. So here the major difference between EFS and EBS is that here many EC2 instances will be able to use that shared file system, elastic file system, and it's a POSIX file system. What is the meaning of POSIX? It's the basic meaning is that it follows Unix file systems with the file hierarchy, the way directories are created, the hierarchical directory structure. All those things are followed inside of elastic file system. Okay. So multiple EC2 instances in different availability zones. So as you see, across different availability zones to share the same shared file system. So if you want multiple EC2s, and those EC2s could be in different availability zones also, to share common files, best use case for EFS. EBS is for one EC2. Let's say you have your application in a single EC2 and you want to store some data and you want quick retrieval. You are not worried about the way the relational constraints and all that. So you go for EBS, the first one. EFS for shared common files you are having, which could be shared between different instances. Go for EFS. Okay. Key points I think we already discussed. Many EC2s can mount simultaneously. Many EC2s can share a single EFS, with shared files. It's multi-AZ, okay, survives AZ failure. One AZ, if it is getting failed, then obviously the other AZs, the workload will then go to the other healthy AZs. So it survives a single AZ failure. And POSIX file compliant, Unix based file structure, and it scales automatically. Okay. EFS automatically grows and shrinks storage capacity. So this is one important point. And it's a managed network file system, fully managed service. AWS handles the underlying infrastructure, patching, backups, everything. Okay, so it is a fully managed AWS service. Quickly, we will look at the best use cases for EBS and EFS. EFS shared upload directly if you want files which could be shared between different EC2 instances. Container management system. So it provides persistent storage for containerized applications running on ECS and EKS. Okay. So if you have application running on ECS or EKS and you want some storage for those containerized applications, EFS is a good bet. Okay. Multi EC2s reading same files. We already saw that. I think this. By now, you should know the important points. EBS, one EC2, one AZ, block storage, many EC2s, multi-AZ, and file system, network file system. Okay. Let's come to S3 now. Everybody would have at least heard about S3, I guess, in any way, shape or form, but may not have got the chance to actually understand, what S3 is all about. So S3 is the full form is simple storage service. Okay, triple S, so that's why we call it S3. It's infinitely scalable. Okay, and ultimately at the backend it is accessed via APIs. It's not a file system. Please remember that. It's best for static assets. So you would have seen that for applications where you require some files from the users to be uploaded, invariably the files would be getting stored in S3. Okay, if AWS is the underlying cloud platform, it is best for that. Static assets, files from the users, all those or some Excel files. It could be any format, PDFs, Excels, etc. Backups of some files. All those things could be stored in S3 perfectly. Okay. If I go towards the major points, it is infinitely scalable object store, not a file system. Please remember that. It is extremely durable. Now, what do you mean by durability? 11 nines, so you see 99 point, these are totally, you would see it would be 11 nines from starting from 99 dot and then 9 nines, so 11 nines durability, we call it 11 nines durability. Okay. The meaning, what is the meaning of durability? It is basically, will the data survive any failures? So if there are any failures happening, power outage, or because it's a hardware, at the end of the day hardwares can fail, as we have seen, due to extreme conditions and things which are not in control. That's why you try to take backups. So the likelihood that data will remain intact and not corrupted over time is what we mean by durability. And the durability which S3 has is 11 nines, which is extremely high. Okay, this is extremely high durability. Availability, how it is different from durability is, can I access my data right now? So it means if I'll get a not available or a 404 from my APIs, or if my service won't be available or would be available, that is the meaning of availability. It's a subtle difference, very similar both the concept, but there is a subtle difference. Okay, so whether data remains intact is what you call durability. Availability is, can I actually access my data, which means if I get service not available at the backend, that means my data is not available. Okay, and it's a AWS managed service via AWS regional endpoints. It's a regional service fully managed by AWS. Okay, so when do you choose EBS versus EFS versus S3? So you need block storage for a single EC2 low latency disk input output. Okay, so it's like a RAM, very similar to RAM, I would say, but not exactly that. RAM has a quick latency, right? When you store cache, since it is not going, only it is very near to your application, so obviously the latency would be low. AZ scoped, here it is multi-AZ, it's a file system, and multiple EC2s wanting to share same files. That's the best use case for EFS. S3 you use when you need infinitely scalable object storage. Okay, so you are designing an application which keeps on uploading some files from your users. So best case would be to use S3 because it is infinitely scalable. And obviously we have seen the 11 nines durability of S3. Okay, so that all those features help S3 for the use case of uploading those files on a continuous basis. Best use case are static assets, like a blogging platform where you have lot of files getting uploaded. All those platforms, you would store those files on S3. Majority of the times that is what happens. Okay, durability comparison, S3 has the highest durability, EFS very high durability due to automatic replication across multiple AZs. Okay, we will look at replication in just a bit. And AZ scope, this is AZ scoped durability. So data can be lost if the entire availability zone fails. So we have already seen that if EC2 fails, EBS still survives, but if that AZ itself fails, EBS doesn't survive. And obviously it's not multi-AZ anyway. We are talking about only one availability zone here, so it's more local. EFS is more multi-AZ. Okay, and S3 is anyway the highest durable out of the three. Let's little bit look at the different S3 storage classes which we have. So we have typically 6 to 7 different classes which you can use inside of S3 for different use cases. Now let's say if you're trying to retrieve data day in day out from a S3 bucket, then the standard is the best. So the default class, whatever comes with S3, is the best. So active data, if you're actively using S3, which could be insert of the files or getting the files that is downloading from S3, whatever you're trying to do, uploading the files, if it is going day in day out, always go with the standard. Intelligent tiering. Okay, So here if the access, like it's an unknown access pattern, so it's not a regular access pattern, but also it is very unknown, it's like the pattern itself is very far-fetched. Like you don't know whether monthly you will have more users, at the start of the month you will have more use. So that pattern itself is very much unknown. In that case you go for intelligent tiering. Here the retrieval time could be little bit higher. That's the downside of intelligent tiering. Retrieval fee again is not there. It is multi-AZ scoped. That is not a problem. Okay. Here retrieval time would be little higher, but it may help you cost wise. If it doesn't help us in cost, we will always keep on using standard. Please remember that, since the access pattern is something which is not in our favor, so we have to have a trade-off with the retrieval time. It may take more time to retrieve your data with lesser cost, but and since your use case is unknown access pattern, so it makes sense for us to do that trade-off, that higher retrieval time for the unknown access pattern. Okay, otherwise since we are not actively using S3, so why should we go for standard? That's the argument which we need to have. So you can go for intelligent tiering if you have an unknown access pattern. Coming to the other one, infrequent access. Now here I never mentioned infrequent access. It was more unknown pattern. It could be frequent, infrequent. We are just not able to find the pattern of that use. Okay, so if that is the scenario, go for an intelligent tiering for the best cost optimization you can do with a higher retrieval time in some scenarios. Okay, so that's the trade-off. Infrequent access, it is a infrequent access, so you are not frequently accessing the data. Let's say it could be once a month or once a week. That can vary, but it is not an active access, like you have for standard. If that is the scenario, you can go for a standard IA. IA is nothing but infrequent access. Here you will have some retrieval fee. That is the downside, with ms millisecond retrieval time, which would be very similar to standard, but retrieval fee would be there. Okay. But the overall cost would be better than standard. Okay, along with the retrieval fee. Since it is infrequent, so it would be better for you to pay the retrieval fee and not the standard costs. Okay. One zone infrequent access. Now here it becomes a single availability zone. It is more, we are little bit okay with some risk. Okay, some risk of losing the data. So we are not going with the multi-AZ. The cost obviously would be lower than standard infrequent access. One zone IA will be less. So we are trying to risk the trade-off, risk the data loss with cost. Okay, and this is for non-critical data. So let's say you are trying to store some non-critical data which is not that important, and it is infrequently accessed. Then a better use case would be to go for a one zone IA with lesser costs instead of a standard IA. Okay, so these are the trade-off you need to do as an architect. Okay, if I am looking at costs and since my data is not that critical, can I go with one zone IA? If your cost is one of the parameters for you to design. Okay, that's how you try to compare the different classes available and go with the one which best suits. You will always want to trade costs with functionality. So that's how you basically weigh the options. Coming towards the Glacier instant retrieval, this is again retrieval time is in milliseconds. It is available multi availability zones. It has a retrieval fee. Now here the archive, it is best for archive data. The data, let's say which you want to archive, which is into the system, but you want it to keep as a backup, and also you want fast retrieval, then go for a Glacier instant retrieval. Okay, and this is multi-AZ. Retrieval fee is there. Glacier deep archive, here what you will lose is on the retrieval time, but you will gain on the costs. Okay, so long-term archive, let's say it's the lowest cost. You know that you have some data. Let's say some research is going on. So there is a institute. They keep on doing the research, and sometimes you just those documents are not being used at all. So you want to archive them. Okay, let's say they are used once in 7 years. Okay, so you don't want to have standard S3 being used for that. You would better want to take them to Glacier Deep Archive and trade off on little bit the retrieval time. It will, let's say you are requesting the data after 7 years, it will take maybe somewhere from this 12 to 48 hours for it to retrieve the data. That's the downside of Glacier Deep Archive, but it helps you in costs. Okay, because it makes sense. If the data is not being used on a regular basis, you are using that data once in years, then you can very well give yourself couple of days more, right, to retrieve the data. Anyway, you are not retrieving it in years, right? So then Glacier Deep Archive becomes the better in terms of cost, as I mentioned, lowest cost. So this is frequent access, no retrieval fee, standard cost whatever are there would apply. Infrequent access, retrieval fee applies. And archival long retrieval times, lowest cost. Okay, so if something which is not getting used for years, maybe once in 5 years I may get a request to get this data, or to do something with this bucket, go with a Glacier Deep Archive or Glacier Instant Retrieval if you want little bit faster retrieval time. Okay, hope this is clear. All the 6 classes are clear. So in terms of the days, quickly I have summarized it already, I have mentioned, but standard S3 is, let's say you are trying to retrieve data once in 0 to 30 days, use a S3 standard. Infrequent access means it is going from 31 to 90. That's an average, it's a general way to think is what they have mentioned. 31 to 90, best use case would be S3 infrequent access. And then if it is going beyond 91 days, which means beyond 3 months, then better to go for a Glacier first version, which is instant retrieval. Okay, and if, let's say if it is like long term, you want to keep it long term and you're okay with a 12 to 48 hour retrieval, then go for Glacier Deep Archive, which is the lowest cost. Okay, so hope this is clear. Little bit we will look at some S3 object logs and versioning. These are some concepts which briefly you should know, at least how compliance is different from governance lock. So let me explain first the versioning. Are there any questions? Hope everybody is able to now there are no issues and everybody is able to follow. Let me start with versioning. Now what happens is a single file may get uploaded multiple times in the same bucket. So if you have enabled versioning, even the first version would be intact. It will be retained. So it restores any previous version of that file. It's not that you are just overriding that object. So that is the meaning of versioning. So you keep the version 1 and version 2 both if the same file is coming again. If versioning is enabled, you get both the versions. Okay, similarly more versions. If next time third version you are putting of the same file in the same bucket, you will have all the 3 versions retained. Coming towards the locks, so S3 there is one thing known as governance lock. Okay, governance lock is nothing but it allows you to it's a restricted delete or overwrite. So let's look at first compliance lock, so what I mean by lock, and then S3 governance lock mode is more a relaxed version of compliance mode. Okay, so immutable fixed retention period. Okay, objects cannot be deleted or overwritten for a defined duration. Immutable means you cannot override that object if you are going with a compliance lock. Okay, This is for some compliance needs. You may require such scenarios where you just don't want the update, okay, cannot be deleted or overwritten. Here in the compliance mode, it's a lock only, but it provides special permissions, to alter the settings or delete the objects, more flexible for internal policies. Okay, so it's restricted delete or override. You are applying the lock, but with a lesser strict mechanism. This is fully immutable, no exceptions. Okay, so if you have defined it for a defined duration, nothing can be updated here. You cannot delete or overwrite. Okay, but in S3 S3 governance, you have some leeway in terms of restricted delete and overwrite. So versioning is undo button, so let's say you want the version 1 back, you will have the version back one back, with a versioning enabled. Restricted delete compliance lock is no delete ever. Okay, so this was about S3. I have covered all the major points theoretically which I wanted to cover, especially looking at the time we have for the session. Let's move to databases here a little bit. So we will look at the relational databases in today's session, and then in the next one we will look at the NoSQL databases like DynamoDB, DocumentDB. Little bit we will touch on Redshift as well. Okay, so let's look at RDS first. So these are the different, majorly these are the type of databases which are available. Okay, so we saw S3, EBS, EFS. They were more file oriented. When you want to store objects as files, they are the ones. Here it is more data which you want to store. So the different attributes which you need to consider when you're trying to design, okay, I need this database or that one, whether NoSQL makes sense or RDBMS makes sense, will define whether you choose RDS or DynamoDB or any other database available in AWS. Okay, so you have to consider whether it is massive scale you are operating, then key value pairs will make sense. If you need the ACID properties, which are the backbone of RDBMS, okay, atomicity, durability, and you have, I'm forgetting C right now, but yeah, you get the point. ACID plus joins is for the relational databases. So depending on your use case, you have to decide whether NoSQL works for you, or whether you need a caching mechanism, or you really need a relational database where you have foreign key constraints between tables, like a order processing system. Generally orders, such systems would need RDBMS, right? And then there are some systems where you require massive scale and you are okay with key value pairs, storing your data in key value pairs. Then DynamoDB or DocumentDB are good platforms to use. Okay, so depending on your data and your use case, you have to decide. And if it is analytical, then maybe it could be Athena as well. Okay. If it is caching, then maybe it could be Elastic Cache. Internally, it can use Redis or Memcache. Okay. So if you need ACID and joins, RDS and Aurora both are relational database systems. In AWS, Aurora is more a refined version of RDS, better in performance. We will look at the details. Better in performance. Basically, if you have some budget, then Aurora is the best. It helps you in the latency, it helps you in the recovery, etc. If you need massive scale, millions of transactions per second is the kind of latency you need, then better to go for a DynamoDB, NoSQL database. If you need analytical queries, if you're doing a lot of analytics on huge data sets, then go for a Redshift. And if you need a caching, as I mentioned, Elastic Cache could be a good service to use. And if you need JSON documents, then DocumentDB is a good option. Okay. Moving towards the relational database service, that is RDS. So RDS is the core RDBMS service in AWS. It's a hybrid. It is managed in a hybrid way. Partially it is managed by AWS and partially it can be managed by you. It's a multi-AZ again. So AWS here manages backups and patching. Okay. And so if you have a use case where you require ACID, joins and SQL, RDS is a good option. Okay. DB engines. Now what are the DB engines it supports? SQL Server, MySQL, MariaDB, Postgre, Oracle. So all these are supported internally by RDS. And as I mentioned, it is not ideal for massive scale millions of transactions per second. If that is the requirement, then go for a DynamoDB. You design your database in such a way that you use DynamoDB. If this is what you need, right? And if you need serverless needs, then definitely not ideal, because this is not serverless. So when you provision RDS, it's like EC2. You will be charged for even if you are doing no query on RDS, which means like in EC2, if your application is not getting any requests, then also it will be charged. Okay, that's the meaning of being serverless and non-serverless, that we have already covered in one of the earlier sessions. So in serverless, you are charged only for the code execution, even though you may be ideal for a long period of time. But here that is not the case. If you provision RDS, you use it or you don't use it, you query over it or you don't query over it, you will be charged. Okay. So if you need serverless needs, don't go for RDS. And if you need a single digit millisecond latency, now if you need this kind of a latency globally, then RDS is not an ideal candidate for this. Okay. I think this is just normal thing. Okay, let's look at one important topic in RDS. So we have multi-AZ and read replicas. Very confusing sometimes to understand these two concepts. Let me quickly in simple words explain this. So what happens in multi-AZ? You do multi-availability zone to get high availability. If getting high availability is your requirement, which means the app is never down. Okay, whenever you request, the app is available. It doesn't say I am not available or service not found or whatever, so it is always available and giving you a response. If that is your requirement, then it's known as multi-AZ. Now what happens internally if you call it multi-AZ is that there will be a primary DB in one availability zone handling the reads and writes. Okay, very simple. What will be there in other availability zones would be a standby replica. Okay, the app cannot access that replica. Very important point. The app would only have access to the primary DB in the AZ1. Okay, and generally it's a synchronous replication. Now what is the meaning of synchronous replication? So let's say the user is updating data in one table, and what would happen is the data would get updated in the primary DB in AZ1. In the same request, while coming back, the data would also get updated in AZ2, the standby replicas. Okay, in the same request. That is the meaning of synchronous replication. Okay, and internally what happens is, let's say primary DB fails. Since it's a synchronous application, in the same call, the other replicas are also getting the updated data. So auto failover becomes easy, right? So if let's say the primary DB fails, then what happens is a secondary standby replica becomes a primary DB. That's it. Internally, it will assign one other standby replica to be the primary DB. And with the synchronous replication, more or less, it will have the updated data. Okay, so it's an auto failover on primary failure. 30 to 120 seconds would be the downtime, the time it takes to make a standby replica primary DB. Okay, multi-AZ is always for high availability, so that your application is always available. But if you are, let's say, looking to scale, what is the meaning of scale? Scaling means your app suddenly have more number of users, okay, and lot of requests are coming, and one database is not enough. The number of requests per second which are coming, it is making it overworked. So what you would do is, then you would look for scaling, okay, because one database can do that much with the number of requests. So scaling and availability again are different concepts. Hope you get the point. Available is not related to number of users increasing per unit time. Availability is you want your app to be available always. Scaling is little different. So if your need is scaling, where you are growing, suddenly you have lot of users using your application, then you need something known as a read replica kind of a functionality, okay. If you need your application to be highly available all the times, irrespective of the number of users which have increased over a period of time, then go for a multi-AZ, where you will have synchronous application, auto failover, and standby replica. The app will not be able to access the standby replica. Remember that thing. But if you need scaling in terms of read, now you want your users have increased, and the number of reads which are happening in the system have increased. They are retrieving lot of data from the system. Okay, then what you would do is you would keep read-only copies of your primary DB. Okay, primary DB will still be used for writes, but for reads, you can have, the app would have direct access to the read replicas. That's the difference. Here there is no direct access to the standby replica. Here you will have direct access to the read replicas you are having, as they have their own endpoint. Okay, please remember that. That's a major difference. And in this way you can scale, because now for read, you are, instead of one DB, you are having multiple DBs at your disposal. Okay, that's the major difference. And up to 5 read replicas is what you can have. And here it is a asynchronous replication. So what is the meaning of asynchronous replication? When the update is happening on the primary DB here, which is taking care of all the writes, the request is returned, the call or the response is returned to the user, and user doesn't wait for the data to get replicated in the other DBs. It just while the request has returned, it just calls the other DBs to update the data without keeping the user waiting. Okay, so asynchronously it will replicate, which means the replication, the user would have lower latency. That's the advantage of having read replicas. When you are trying to scale, what are your major constraints? So you need to have lower latency for the increased number of users. So obviously synchronous replication will not work in that scenario. Synchronous replication will have a longer latency. It's a very common sense, right? If I am updating the data in the same request, I'll take longer time. But if, let's say, I'm just updating the data and returning, and my request is over, request response, both the parts are over, and then I just make a request to the other DBs to update the data, not in the same request, then I'm saving the latency part of it. So that's how asynchronous replication helps here, because you are looking to scale and there are more reads happening. That's how the two are different. Hope it is clear. Any doubts, I can answer the questions. Generally, what happens is, first you will enable multi-AZ for high availability. Okay, that is what generally happens. I'm telling you the general procedure. Then as the reads increase, let's say your application becomes famous, more users are retrieving the data from that application. For example, your news websites or blog websites, there are a lot of reads happening, right? Updates are less. So you add read replicas so that the latency on reads become lesser, and you are able to match the load of the users, correct? So you start with making it multi-AZ, and then you move towards making it then you move towards having read replicas for scaling. These were the major points on RDS. Let's quickly look at Aurora. So Aurora is typically, we call it an optimized RDS. Okay. So it's a fully managed DB service again by AWS. You have MySQL and PostgreSQL compatible. Okay, so these are the two engines right now it is compatible with. Obviously it is faster than normal RDS, and it would be costlier than RDS. Okay, that's the downside. And so we'll see how it is different from RDS. Okay, the replication is the time it takes to replicate the data, is quite less than 1 second for Aurora replicas in same or different AWS region. Okay, while for RDS it is few seconds to minutes. So RDS, since it's a basic, it's more of a you would use RDS in your dev environments, and let's say you have lesser budget. If you have more budget, then generally people would transition towards Aurora. That's the idea. You will have lesser latency in even replication. It's deployed as a DB cluster, one primary for read and write plus multiple read replicas. Okay, for scaling you will have read replicas with asynchronous replication, while primary would do the read and write anyway. Okay, Aurora primary read write is there. Then you have the application. I think this is just Aurora replicas 1 and 2. So for read only, less than 1 second replication lag. Now for read replicas, we mentioned that it is asynchronous replication. Now if it is asynchronous replication, we have to look at what is the replication lag, right? So that time also should be lower, otherwise your other users which are routed to your second read replica, may get stale data, correct? Since it is asynchronous replication. So you want this time to be as low as possible. In RDS, this time could be from seconds to minutes. So, then you are providing a stale view of your application to the users. In Aurora, this is even lesser than 1 second. Okay, that's how it helps in replication. It's a high performing relational DB. I already mentioned multi-AZ. Global read scaling is possible via read replicas. We already saw that. It is not suited for NoSQL use cases, smaller workloads, and if your budget is less, then go for initially RDS. Startups start with RDS generally. If their requirement, if they have lesser budget, and they are okay to have more higher latency because users are also less anyway at the start. So start with RDS and then upgrade to Aurora is how it works out. Okay, and you also have a AWS Aurora serverless. Okay, serverless means this is used when your app has unpredictable usage patterns. You don't know when the users are going to come and use the application, so you are not able to predict that. It could be seasonal or spiky workloads. For example, when there is a festival season, you have spiky workloads, high usage at the start of the month and low later. So such kind of scenarios, better to go for a Aurora serverless. When you are difficult to predict the app demand, or difficult to predict the right instance size, then also it's a good use case for Aurora. And you want to stack it up with other serverless applications or serverless services like Fargate. Then you will have a DB which is serverless in Aurora. Okay, so it becomes basically you are using a serverless stack with AWS as your engine, compute engine, and Aurora serverless as your DB. And you want microservices migration. So let's say you're converting your monolithic app to microservices architecture, then it's a good use case to use Aurora for RDBMS kind of stuff at the backend. And it has auto scaling available. So what happens is if you have low traffic, Aurora will be, the scale would be lower. the number of instances it will employ would be lower. As the traffic increases, it scales up automatically, and when it drops again, it scales down. Okay, so that's an advantage which Aurora has. It is, we already saw this, unpredictable workloads, dev test environments. I think for prod also it is good. And serverless application stacks, it augurs well with Fargate. So Fargate plus Aurora is a good serverless combination. Okay, and if you're going to modernize monolithic to microservices migration, it's a good use case for Aurora. Okay. There is one more topic known as Aurora Global DBs. Okay, now if your app is a globally distributed app, right, which means you have users, in different parts of the world using your application. May not be the only country where the app is getting developed. Maybe in US also you have a lot of users, and other different places. So if you have that kind of an application, the one Aurora DB can span multiple AWS regions. That is one thing. So for a unified global data access, you can have one single logical database, which helps you access the data from different places on the planet. Okay, so you have Amazon Aurora Global DBs for that, for globally distributed apps. What is the RPO and RTO? Now, recovery point objective of just 1 second. Okay, so what happens is, in RPO, let's say you are taking backup every 1 hour, just an example, and your app is crashing at 11:45. It is 11 o'clock, and then 12 o'clock, you will take another backup. Your app crashes at 11:45. So what is the RPO? It is 45 minutes. Your data would be older by 45 minutes. You don't have backup of that 45 minutes because your backup is happening every 1 hour, and in between the app crashed, and then so that's the meaning of RPO. How much data am I losing because of any failovers. Okay, and what is RTO? It means for me to get the other instance up and running, the standby replica up and running, how much is the time it is taking. Okay, so it has a RTO of 1 minute. That RTO is among the best. So RTO for RDS would be really high. So it helps in having lesser RTO, recovery time, and so it helps you in faster failover. So the other DB would come into play in 1 minute. Recovery time objective, and this is more on the data side. How much data am I losing? That is just 1 second. Imagine. So the point objective is just 1 second for Aurora. So just 1 second's worth of data may be lost. That's the amount of RPO it is providing. Okay. So async replication, less than 1 second lag. We already saw that. Just providing some good diagram just to properly understand. RPO is 1 second, recovery time is 1 minute, replication lag is less than 1 second. Okay, these are the three key statistics for Aurora, and if you have the budget, go for Aurora. It helps you in these three statistics or data points, while RDS would be, all the three would be high. Okay. Okay. And obviously the global DBs for Aurora is for globally distributed applications. Disaster recovery with aggressive RTO, RPO is the best use case for global DBs, and low latency reads for global users. Okay. We will stop here as we are anyway on time. I'll wait for a couple of minutes if there are any questions, and we wind up after that. Next session will be on DynamoDB, Redshift, Athena. All these platforms, database services we will look at. DynamoDB is a NoSQL service, highly used NoSQL service, one of the most common NoSQL services in AWS. Everybody should know DynamoDB, as you must know RDS and Aurora for RDBMS. Okay. Hope it was a good session. You at least got the major points of the different services. If you're just getting started, this helps you. And with the series which I'm taking, we will also do, along with theory, some hands-on coding, where we will look at how we provision different services in AWS, and understand how the different resources are created. It could be any provisioning platform. I generally use TFE, Terraform, to provision resources in AWS. So we'll look at that. Those would be later on in our series. First we should complete the theory so that people understand actually what we are talking about, and we take it from there. Okay, so if there are no questions, we will wind up, and I'll see you in the next one. I'll wait for half a minute, and then I'll close the meeting. Thank you guys. And by the way, let me share you the feedback form, those who have not filled it till now, just to get a perspective if I need to change anything. I think there are few guys I see who have joined for the first time. Please fill this up. I am also asking if you want to be a part of a community. We are trying to build a AWS and AI builders community, where we will do AI plus AWS, a lot of different use cases we will try to take in the future. And we take, and it helps us create an inner circle of people working or using AWS in their day-to-day life. We try to learn from each other, and there would be different updates as well in the platform, like it happens with different communities. So if you're okay, you can just tick that option. And we are not onboarding or starting the community right now. We are looking at the number of people who are interested. From that we will take a decision, and then we will start it off. So it will take some time for that to happen. But yeah, as you provide the feedback for the session and whether you're okay to be a part of that community, you can put it in the form. So Gautami, just to answer your question, generally we don't share any recordings. It's a free session I am doing. I want people to take notes. That's how you learn, and we will be doing it again. It's not an end. So once we complete one cycle, we will again start off with the basics of IAM and networking, and the different components which we have done previously. So let me complete one cycle, and then again we will take up those sessions. It's not that you have to first know them, then only you can attend these sessions. It's not like that. You can still attend, and then future sessions which you missed, we will do in the second cycle. Okay. Feedback form, is it? Okay. Oh, okay. Yeah. I think I made a mistake. Sorry about that. Yeah. So we have a consulting. We are also doing some consulting in the finance space. So that is for that. You can click on the second one. That's the one for our meetups. I'll stop the recording now and wait for half a minute, and then we will